Hey there. Today we're starting chapter 4. 4.1 is on congruent figures. We've talked about congruent angles and congruent segments and stuff. Today we're going to talk about like a full polygon, a figure that is going to match up and be congruent. So the definition of having congruent figures means that you have polygons that have congruent corresponding parts. That means all their parts match up. Their angles, their corresponding angles are congruent, their corresponding sides are congruent. If you look at this example of these two triangles, and it's important that you kind of pay attention because sometimes the figures are deceiving looking, and so you have to pay attention to the phrasing. They say triangle LMC is congruent to triangle BJK. The order of these letters is important. They have to match up. So this L corresponds to this B. So over here in the picture, that means this angle here actually corresponds to the angle over here on the right. So it's almost like it's been reflected, like there's a mirror image here. Because you can see that M corresponds to J, so that would make sense. But then you have C corresponds to K. That's these two close ones. What that means is when you're picking out congruent parts, you have to pick them in the right order and you have to find the right part that actually corresponds. Knowing that those triangles are congruent, it says complete the congruent statements. So segment LC is congruent to what? Well, LC is right here, so that would correspond to this one right here. It's good habit, though, to put it in the correct order. L actually corresponds to B, so I'm going to put the B first, and then I'm going to put the K. So I'll put segment BK, like that. All right, let's go over to 11. Segment KJ corresponds, so KJ corresponds to, well, it'd be this mirror image right here. Again, K and C are the ones that correspond, so let's start with C and then M. And to be honest, it's really probably even faster if you just simply look right here. Now, if you have this congruent statement, just match them up. LC, that's the first and last, matches with first and last, BK. Over here, KJ, that's the last, and then the second one, so I'm going to go last, second one. All right, so let's go ahead and do a couple more of these. Next one says segment JB, so if I look up above, just at the congruent statement, JB goes second and then first, so I'm going to say ML. Make sure you practice that notation. You're talking about a segment. Angle L would have to be congruent to angle B. All right, why don't you finish these 6 out on your own and then come back when you're done. Pause the video. Okay, here are my answers. Check yours, make sure they agree with mine. And I'm looking at the order of the letters. That's very important that you keep the order correct. If you've checked it and you're good to go, keep going. If you need to look over something, then pause the video and do that. Okay, now let's talk about, we've done a few theorems about triangles in the past, like the triangle sum theorem, but this is a new one for us. It's called the third angles theorem, and it says that if you have these two triangles here, and you know that angle A in one triangle is congruent to angle D in the other triangle, so you know these angles are congruent, and you happen to know another set, B and E, then that means that the last set have to be congruent. So if two angles of one triangle are congruent to two angles of another triangle, then those third angles are congruent. We call it the third angle theorem. If we're doing a proof, that's actually what we write, the third angle theorem. That's kind of our shortcut. We don't have to write it all out. If you know two sets are the same, now this is a proof, and what we're trying to prove on this is kind of a new type of proof. We're proving two triangles are congruent. Well, the only way to show that those triangles are congruent is to show all their corresponding congruent parts. So that really means I got to have 6 congruent statements in here. 6, I got 3 angles to show congruent, and I got 3 sets of sides that I have to show congruent before I can say those two triangles are congruent. Now, they've given me a bunch. 1 congruent, 2 congruent, 3, 4 congruences, And those 4 congruences are already marked in my picture. So I'm going to go ahead and put in given, but I can see right here, this is not all of my given. They have so much given, they're spreading it out a little bit. This right here is a given statement also. So I can just write both of those. Now, why do you think LN is congruent to LN? So what they're saying is that LN here in one of the triangles would be congruent to LN in the other triangle. Okay, you have to make the congruence. It seems like it would be obvious. Yeah, they're the same. But you're trying to show that, hey, this side in one triangle congruent to this other side in this other triangle. And you have to make the statement. And this is finally where that weird property that we have, where remember you have the same thing on both sides. It's like a reflection. That's called the reflexive property. That's a place where you would actually use that reflexive property. Whoops. Property. Okay. All right. So now I'm going to go ahead and mark that. 1, 2, 3. Okay. So I had 4. That's 5 congruences. The next congruent, this is my last one, angle MNL. MNL, that's this one here, is congruent to ONL, that's this one. And they're saying these 2 angles that have to be congruent. Well, I'm kind of thinking like angle bisector or something, but it doesn't say anything about an angle bisector. What I do know, though, is that in these 2 triangles, I already have 2 sets of angles congruent. These 2 are congruent, and then I have these 2 congruent. I'm going to use my new theorem. If 2 angles of one triangle are congruent to 2 angles in another triangle, then the third angles are congruent. We call that the third angle theorem. And that's my 6th congruence. I have now proven that these 2 triangles are congruent because I've shown all their corresponding parts. I'm just going to call that definition congruent figures, or polygons, or triangles. Actually, this is probably what I'd do. I'd probably go ahead and just call it definition of congruent, and I'd call it triangles, since that's what I'm dealing with. And this is how I notate that, triangles. S for plural. All right, now on the next slide, you're going to have one more proof. You're supposed to do that one on your own. So give it a shot. Do your best. If you need to come back, if you get kind of through it and then you need to come back and peek, that's okay. You can do that, but you got to try it by yourself first. So take a minute right now, pause the video, and do the next proof. Okay, here's the result of my proof. The thing that was different in this one, I had to do a vertical angles are congruent statement in there. That's how I got my second set of angles congruent. Once I had my second set, then I could do that third angle theorem, and they gave me all the sides, so that was all I needed. Definition congruent triangles. How'd you do on it? Well, thank you for at least trying it, if you at least tried it. All right, so we're going to definitely be doing some more proofs in this chapter. Go do your homework. Good luck.